All right, guys, how are you today? Happy Wednesday. If you're watching it the day that I posted it, if not, happy whatever day it is. Hopefully, not far from Wednesday. I appreciate those who have hopped into their Monday video and went over a couple things that we needed you to be fresh on, efficient with, and confident with. So thank you for looking at that. If you haven't yet, hop on and do that. You can do it at this very moment, or you can watch this first and then go back. But make sure that you're taking a look at that and then following along with this video as well. So here I have a couple more skills that I just want you to be proficient with and confident. These aren't just things I'm asking you to do because I want you to think about middle school math or even earlier than that. These are things that we're going to need you to be confident with because they're skills that we build off of here in Algebra 1. So this first one here, you can already tell, is about greatest common factor. I just want to jump right in. That should hopefully sound familiar to you. We also call the greatest common factor, you'll notice, or you've heard it called the GCF. Kind of self-explanatory there. But this is the greatest common factor is the largest. Oh my gosh. That's an L at front, I swear. The largest factor that the numbers share. So we need to know then that's where the greatest part of that comes from, but we need to know what factor is then as well. What are factors? A factor is a number that divides another number evenly with no remainder. So I want to give you an example, just if I'm asking you for the factors of a number. If I'm asking you for the factors, let's say, of 24, right? We're thinking what divides 24 evenly without a remainder. So one that'll always come to mind is 1 times something, right? 1 and 24 are factors of 24 because 1 times 24 is 24. What else is a factor of 24? You're probably thinking 2. It's even, so 2 goes into it. 2 times 12. Does 3 go into 24? Yes, it does. 3 times 8. Does 4 go into 24? Yes, it does. 4 and 6. When you notice these numbers get real close, like 4 and 6 are, you're pretty much there. Think about 5. Does 5 go into 24? No. Right? 5 times 4 is 20. 5 times 5 is 25. 24 gets skipped over. So once you get that far, the next number would be 6, right? We've already used 6. So this is our list. You might have had some teachers also just list them out, or you've seen them listed out. Like here's 8 numbers, right? 1, 2, 3, 4, 5, 6, 7, 8. Sometimes they're just listed like that in order, right? 1 and 2 and 3 and 4 and 6 and 8 and 12 and 24, right? Same 8 numbers. They all include just the list of those 8 factors. So there you have it. Let's dive into one where we need to find the GCF. I don't really think I mentioned up above here, but common, like if I say you and I have this in common, it's shared. It's the same, right? So we're looking for the largest factor. We just looked at how to find a factor. The largest shared factor of these sets, right? AKA we can call it the, like we said, the GCF. All right, the factors of 12 and 20, the best way I think you can do this is just to kind of look at these numbers one at a time. One of the factors of 12, write them. 1 and 12, because 1 times 12 is 12. 2 and 6, because 2 times 6 is 12. And 3 and 4, because 3 times 4 is 12. All right, what else? We got 20, because there's no more factors of 12. Factors of 20, 1 times 20, 2 times 10, 3, nope, 4, yes, 4 times 5. Again, look at how close 4 and 5 are. As soon as you move up from 4, you get to 5. 5's already listed. We're done. Greatest common factor. They both have a 1. Great. They both have a 2. Great. They both have a 4. Great. They don't have anything else in common. Again, greatest common factor. So our GCF of 12 and 20 is 4. All right, let's take a look at this next one. Greatest common factor of 16 and 28. Factors of 16, you're thinking 1 and 16. You can pause my video if you want to do these on your own. I highly encourage that, thinking for yourself instead of Mr. Neal thinking for you. We have 2 times 8, and is that it? And 4 times 4, right? If you were writing a list out like this, you wouldn't necessarily have to write 4 twice, same number. I just like to write the pairs. It'll help you later in our algebra class. I have you do something where you list all these out as well. Factors of 28, 1 times 28, it's even, so I know 2 goes into it. 2 times 14, and 4 times 7. What are my factors that are common? 1 and 1, 2 and 2, 4 and 4. There's a 7, there's an 8. Those aren't shared, so it looks like the GCF again here. That's a G, I swear. Terrible looking G. Is 4. Last but not least, you might get three numbers. What is the GCF of 20, 28, and 36? Let's find out. 20's factors we listed over here. Let's copy those down. 1 times 20, 2 times 10, and 4 times 5. We keep seeing 4 on these lists. GCF of 28. We just saw 28s, right? 1 and 28, 2 and 14, 4 and 7. 36's factors. They have 36 has got a decent amount. 1 times 36. 2 times 18, 3 times 12, 4 times 9, 5, no, 6, yes, 6 times 6. It's a matching set of numbers. We don't have to go any further. Now we need the greatest factor that's in all three of these lists. There's a 1, 1, 1, there's a 2, 2, 2, there's a 4, 4, 4. And they have nothing else in common. The GCF of 20, 28, and 36 is GCF is 4. Why do we keep getting 4? I promise you other GCFs are numbers other than 4, but for whatever reason, the numbers that I picked for this example has an answer of 4 on all three problems. All right, hopefully that's enough to give you a quick recap of GCF. I wanted it to be just a couple minutes or less. Let's move on. Something you learned right around the time you learned GCF was this least common multiple, okay? They kind of go hand in hand. I'm not sure which one you learned first. I don't really think the order of which of these two you learn is really all that important, but you learned it nonetheless. You've seen it. We have here, what is the least common multiple? The least common multiple is what was I thinking here? The blank positive number, or the smallest. The smallest positive number that is a multiple of both numbers, right? So we need to know the least, right, is where it gets smallest. Common, again, just like up above, is shared. Multiple is the kind of almost the opposite of a factor, right? When we multiple, you think of multiply. If I'm going to list multiples of a number, we'll give an example. Here's a list of 5 of the first 5 multiples of the number. Let's go with the number 7, right? So I need to list the first 5 multiples of 7. Well, 7 times 1 is 7. 7 times 2 is 14. 7 times 3 is 21. 7 times 4 is 28. 7 times 5 is 35. And 7 times 6 is 42, right? You're also noticing every time I move up a box, yes, I multiplied by one number bigger. Multiplication is like repeated addition. I'm really just doing this. Plus 7, plus 7, plus 7, plus 7. I'm adding 7 every time. My multiples, again, I kept saying 7 times 1, 7 times 2. This is in the first spot, the second spot, the third spot, the fourth spot, and so on and so forth. So, shortcut, I'm not really going to ask you this. I'm not sure. I don't think I'm going to ask you a question like this year. But if I say something like, what's the 8th multiple of 5, right? Just do 8 times 5, right? 40. If you don't believe me, write them out. 40 would be the 8th multiple of 5. All right, so down here below, if we're wanting to find the least common multiple of a set of numbers, right, I need to have at least 2 for it to be in common. You can't have something in common if you're by yourself. A 4 and 10. Pause for a second or just think. Can you just think of this in your head? If I listed out 4s and if I listed out 10's multiples, right, could I find them? All right, so let's think about this. Let's write out 4's multiples for a little bit. We have 4, then 8, then 12, then 16, then 20, then 24. I'm going to stop. Let's write out 10's. 10 and 20. Nothing's in common yet. There's no 10s or 20s above. Oh, wait, yeah, there is. 20 and 20. The LCM of 4 and 10 is 20. Right? Nothing else is in common. That's the smallest number that's on both lists. Let's think about this next one. Least common multiple of 5 and 15, right? So what if I list out 5's 5, then 10, then 15? Well, wait, I can stop. 15 is my next number, right? If I start my next list, 15, do I even need to do my second multiple of 15? No. The least common multiple of 5 and 15 is 15, right? 5 goes into 15. You might have noticed that right before I even got to it. Last but not least, we have the least common multiple of 4 and 9. So let's list out some multiples. We have 4, 8, 12, 16, 20, 24, 28. Squeeze that in there. Let's see if we have one if I start with my 9s. 9, 18, 9 times 3 is 27. Nothing shared yet. 36, nothing shared yet. This list has gotten up to 36. Let's hop back to our other list. After 28 would come 32, then 36. Boom. We have a shared number. There's no numbers on both lists that are smaller in common. So our LCM is 36 for the number 49. All right, that'll give you hopefully a quick debrief of that. Let's keep scrolling here. The third and last topic that I want you to focus on today is this. Also should look familiar. Order of operations, right? Which you're thinking, hey, what's this acronym over here, right? We had GCF for greatest common multiple. We have LCM for greatest common factor, least common multiple LCM. We have this PEMDAS here, right? So that should look familiar. Please excuse my dear Aunt Sally. What else? Another student told me in the past, pandas eat milk duds and Skittles. I'd never heard that one, but he said that that's what he was told to remember that, and that's how he remembered it. So you might have your own. I have no idea. You can make up your own. If not, get creative with it. But anyways, why do we even have this? So think about this problem I have here on the left and on the right. I have the same exact problem, right? If I asked you to do 7 plus 3 times 5, you might already have an answer in your head. I didn't pick a very challenging problem here. Let's figure out what that is. If I do 7 plus 3 is 10 times 5, right? What's 10 times 5? 10 times 5 is 50, right? Well, the person to your left or to your right or in front of you or behind you or anywhere could have done this, right? What's 3 times 5? Well, 3 times 5 is 15. They haven't messed with that 7 plus yet. 7 plus 15 is 22, right? Somebody noticed a long time ago, in a galaxy far, far away, actually it was probably in our galaxy, that we can't really be giving people the same problem, two different people the same problem, and getting two mathematical answers. That's just not right. So I have listed here in this sentence below, to answer this question, why do we have order of operations? We need an agreed upon order that math expressions and statements are completed, right? We can't give you a problem and say, do it. Hopefully you do it like the guy to your left and right, because if not, then we're going to have a serious debate. So somebody much, much smarter a long, long time ago, somebody that was very, very dead, came up with this order that we should be following. So the order is, for this PEMDAS, right, is P is for parentheses, right? E is for, what's E for? It's for exponents, right? M and D is for multiplication and division. And I always draw an arrow like that next to it. I'll explain why in a second. You might already know why. And then the AS is for addition or add and subtract. And I have that there as well. The reason I have those arrows, if you have both multiplication and division, do them from left to right. Same thing with addition and subtraction. If your problem has addition and subtraction, when you get to that step, do them from left to right, because they hold like the same rank. They're both ranked 4, and these are both ranked 3. Only exponents is ranked 2, and only parentheses is ranked 1. So you would just do those if you come across them. Let's try a couple examples here that I think will just be good for kind of hammering this stuff down, seeing it and getting it moving here and kind of waking up that middle school mind there. All right, so let's follow these orders. We're looking at this problem here first, right there. I'm going to draw a line here just to kind of separate these problems so they don't blend together. Let's look at this one here on the left. In parentheses, 75 plus 9 to the power of 2 over, which is divided by 2 to the power of 2. So do we have parentheses? Yes. I look inside of those parentheses. In the parentheses is that whole expression, 75 plus 9 to the power of 2. Now that I'm inside of those parentheses, right, what's being done? I see addition and I see an exponent. Well, what comes first up here? Addition or exponents? Addition is down here. Exponents are right there. We need to be doing the exponent first. So 9 to the power of 2 is 81 for all you crazy math nuts out there, right? Because it's 9 times 9. 9 times itself 2 times. So now I have 75 plus 81 over, in parentheses, over 2 to the power of 2. So I restart this list, right? This checklist. Do I have parentheses? I still have parentheses. What's inside the parentheses? Inside the parentheses is 75 plus 81. I don't really have a decision to make. That's the only thing in there to do. So I'm doing 75 plus 81, right? Which is, what is that? 156. If my math serves me correct, 156. I'm doing that because parentheses come before this division and they come before this other exponent. So divided by 2 to the power of 2, right? Okay, so now I'm thinking, what's left? I see division here and I see an exponent. Well, look at this list, this checklist, go from top to bottom. Parentheses, none left. Exponent, yes. Do the exponent, okay? So now 2 to the power of 2 is the same thing as 2 times itself twice. So I have, that's 4, 156 divided by 4. There's really nothing else to do besides that division, right? We've got rid of the parentheses. We got rid of both exponents. The only thing left is this fraction. Fractions mean division. So now I need to do 156 divided by 4. 156 divided by 4. Take a second to figure out what that is. Do you know what 156 divided by 4 is? I'll be very impressed if you can do it without a calculator. What is 156 divided by 4? We get, oh my gosh, I'm having a total brain fart here. Divided by 2 would be 75, 78. 78 divided by 2 would be 39. Okay, check my math there. Grab a calculator if you want after you've tried that as well. That answer, the most simplified version of that expression and statement up above, is 39. All right, let's dive into this next one here in the middle. So in the middle, we have a lot going on here. I'm going to read it from left to right. We need to start using our checklist up above. 2 times 8 squared plus 7 minus 7 times 6. A lot going on. Let's just go ahead and follow these order of operations. Make this thing make a lot more sense in our head here. Parentheses, do I have any? Nope. Move on. Exponents, do I have any? Yes. I have 8 to the power of 2. It is not 16 because that is not 8 times 2. The amount of times that I hear the answer to 8 squared is 16 is kind of mind-blowing, right? It's 8 times 8 2 times. Excuse me. Let's rephrase that. 8 times itself 2 times. So 8 times 8, 64. So now I'm going to write down, I didn't touch this 2. 2 times 64 plus 7 minus 7 times 6. Start our checklist again. Parentheses, no. It's a terrible looking 64. Let's fix that. Parentheses, no. Exponents, no. Multiplication or division, yes. I have multiplication here, and I have multiplication here. Remember, we do it from left to right. So 2 times 64, let's knock that one out first. That's 128. 128, I'm going to bring everything else down. I just did this. Plus 7 minus 7 times 6. Okay, checklist, parentheses, no. Exponents, no. Multiplication, still, yes. 7 times 6, which is over here. That's 42. I didn't touch the subtraction or the 7, and I did not touch the 128. All right, that's a plus there. Right, checklist one more time. Parentheses, nope. Exponent, no. Multiplication, no. Division, no. Addition or subtraction, yes, I have both. Let's do them from left to right. So 128 plus 7 would be 135. 135 minus 42 is our last thing left. So I just need to do 135 minus 42. And that should be 90. What do we call it? 93. Right? So this just got simplified down all the way to 93. Last but not least, let's check out this one on the right, and then I'm going to get you guys on your merry way to test out these skills, get them hammered out and confident before we meet in person next week. In like 5 days from the time I post this video. Crazy, crazy, crazy. 6 days, I'm sorry, we have a holiday. Labor Day. Anybody have any Labor Day plans? Anybody? Going once? You can't hear me. We're not talking live. If you have them, tell me the next time we meet. All right, let's go ahead and go through our checklist. We have parentheses in this problem. We do not. Exponents, we do. 4 to the power of 2 if you're thinking 8. Give yourself a little smack on the wrist. No, not 4 times 2. 4 times 4, 16. So I'm going to change this guy here to 16. I'm going to bring everything else down. So we have 6. I don't like these little X's. You're going to see them on Delta Math, right? You know what that X is. It's multiplication, but we really like using the dot like the previous problem over there in between that 2 and the 8 and the 7 and the 6. We have 6 times 8 plus 4 times 16 plus 6. Check this again. Parentheses, no. Exponents, no. Multiplication, yes. I have a couple of them. I have 6 times 8. And I have 4 times 16 over there, but we do them from left to right. 6 times 8 would be 42. Right? Yes. Ooh. No. Oh my gosh, 48. Ooh. I need to. This is why it's good that I'm doing this as well. I bring the other things down because I touch one piece at a time. Plus 4 times 16 plus 6. Checklist, parentheses, no. Exponents, no. Multiplication, yes. Right here. 4 times 16 is 64. I'm going to bring down this 48. This addition, and I'm going to bring down this addition of 6. The only two things I have left are addition. I do them from left to right. So let's go ahead and add this 48 plus 64, which would be, that 48 is really close to 50. Think about 50 plus 60, 110, right? Add the 4, 114, take off 2, 112. And then an addition of 6 at the end there. 112 plus 6 is 118, right? Boom. Okay. So thank you for following along. This is nothing that I'm sharing with you that is 100% new, unless you snoozed your way through a lesson or lessons. I hope that was not you. But you may watch this video as many times as you want or need. You're going to have a follow-up Delta Math assignment on this. Just these 3 topics. So can you just kind of hammer some of these out, practice them, have them sharp and ready to go for when we finally get to hop into the classroom on Tuesday of next week. Thank you for following along, and hop into our next live session if you have any questions. Sorry if the camera angle was weird. I don't really like the camera angle here on this when the tablet's not sitting on a desk. It's hard to write when it's on a desk and up. So thank you for bearing with me. See ya.